We're the Monkey Shooters. I'm Richie.
I'm Danny. I'm Sibylla.
And I'm Kaylin.
And today we're going to be talking about the physics of beer pong.
Typical night at San Diego State.
Danny, I can't get it to go in.
I don't understand why I can't make it.
God,
Hey guys,
so
what's
hard.
up?
Oh, nothing. We're just playing beer pong.
It's really hard.
Dang, for being so good at physics, you guys suck at beer pong.
Hey, physics has nothing to do with beer pong.
Physics has everything to do with beer pong.
How do you say?
Look, you're about 1.5 meters away. I would say this cup's about 0.127 meters high. All you have to do is just figure out how fast you have to throw it in order to make it into the cup.
So?
Well, according to my calculations, the height of the ball above the table is about 1.127 meters. But the cup is 0.127 meters tall. So you just subtract the cup from the original height and you get, coincidentally, 1 meter.
Huh.
Oh.
The time it takes to reach the cup is in the equation t equals the square root of 2y naught over g. And that equals the square root of 2 times 1 divided by 9.8 meters per second squared. All square rooted. And that equals 0.452 seconds.
You don't say.
Now that we know the time it takes for the ball to hit the top of the cup, all we need to figure out now is how fast to throw the ball. Sevilla was standing about 5 feet away from the table, or the cup on the other side of the table. This is 30.48 centimeters, and you just divide by 100 and you get, wait, 1.524 meters.
Oh.
Since velocity equals d over t,
Oh yeah, we learned that in physics.
1.524 meters divided by 0.452 seconds equals the velocity you have to throw it in order to make it to the cup.
Which it is?
3.37 meters per
It's a
second.
good thing you have so much time on your hands.
You got that right.
Well, if you're so good at physics, why don't you try and make it?
I would. Hold my calculator. I gotta go. I've got an 8 o'clock class. 8
want your
a.m. class
calculator?
to get.
Okay, so we need to remember to throw the ball at 3.37 meters per second.
Right.
Okay.
Hey, Kaylin.
Hey guys.
Hi.
Hi. It's kind of hot in here. How about we turn on the fan?
So what are you guys doing? Kaylin, you can play with my balls.
Really? You never let me. So I'm throwing it 3.37 meters like you guys said, and why isn't it going in?
I don't know. Let's call Richie. Richie, we need you to get over here right away. We're having a huge dilemma. When is Richie gonna get here?
Got here as soon as I can. What's wrong?
We still can't get the ball in the cup.
Get the fan going. That's why your balls are dropping.
So what do we do?
Guess we're gonna have to make another calculation. By taking the two velocities, which are 3.37 meters per second, which is what the ball was originally traveling at, and 1 meter per second, which is what the fan makes the ball travel in the x direction, we can now add the two vectors together to get the new vector, which is 3.37 meters per second. This is the new velocity the ball has to travel in order to make it into the cup. By Pythagorean theorem, we figured out that the velocity is 3.4 meters per second, and the angle at which you have to change the velocity is 0.005 degrees.
So that means, Richie, if I move it up just a little bit, that I'll be
So
able to
I'm
get
gonna try this time, but guys, can you turn the fan off? That stuff is just too confusing for me. I just want to do it the normal way.
So remember, 3.37 meters per second. So now we figured out the physics of beer pong and how physics is part of everyday life.
We want to remind you guys that no alcohol was consumed during the filming of this project. because it took the whole project for us actually to make a cup. So, we are the monkey shooters, and we will see you around.
Bye.